Okay, so yesterday we looked at the family of functions. We did this one, which was linear. What we did was we made a T-chart. And we plugged these numbers in and we graphed them. And it was a straight line. After you plotted them, it was a straight line. We did the quadratic one. And this one was every time you plug the x in and you square it, you get 9, 4, 1, 0, 1, 1, 2, 4, and 3, 9. And that's what these points are. Over 1 up 1, over 2 up 4, and over 3 up 9. And we did the cubed function. And this one looked like this. This is what we did yesterday. And we did the absolute value one. Looks like a V. And we did this one. This is the square root one. Like that. And we did the cube root one. It looked like this. And the reciprocal one, which was we had an asymptote and we had these two nice pieces. Okay? Now what you're going to see today is all the transformations. If I were to take an equation, I could transform it by doing all kinds of things to it. So if you look at this new function, you have to be able to identify the parent. What is the parent function?
Y equals x. Square root of x. Square root of x.
Is y equals the square root of x, yes. If you were to remove this, this, and that is the parent function. So if I gave you a variety of different, if I gave you this one, and I said, what's the parent function? You would be able to say, it's the cube root. What these things do, a number in front, a number inside, a number after, it transforms it into the same shape, but it's going to look a little different. It's going to be shifted. It might be shifted left, right, up, down, upside down. You have to be able, and I'm going to teach you how to recognize what each of these things does. Okay? So, let's start with, and I gave you guys notes yesterday on the parent functions, so you might want to keep them handy. And I'm going to give you 2 more worksheets that we're going to work with today. If you don't mind taking one of each of these and just circulating them around. So let's take a look at this. And actually, I'm going to give you a little recipe here. I want you to write this down somewhere on your paper. This is going to be very important. Write it on either one at the very top, or you can even, if you want to, you might want to take out a separate sheet of paper and write some of this stuff down. It'll be very, very helpful. I will grab a sheet of paper and write this stuff down. C, A, okay, write this down. This is very important. I want you to understand the position. example, if I gave you this function, and I'm gonna make this square. Okay, first of all, where is the A value? The A value is tucked inside, and it's inside of the grouping symbol.
Four.
It's the 4, yep. Now, what do you notice about the A up on top and the B value? This is
They're
important.
separate parentheses, or separate
Yes.
sections of the equation.
It's separated, yep. You have to get the B value, a lot of people think, okay, A is 4 and B is 12. B is not 12. You have to good job, B is 3. What you need to first do in all of these problems, and I'm giving you a difficult scenario. You may not see it this difficult. So, I'm giving you the tougher problems right now. So, that's what I want you to see, is that B is not negative 12, it's negative 3. So you want to isolate A first and foremost, okay? So does everybody see what A, B, C, and D are? A is 4, B is negative 3, C is negative 2, and D is 7, okay? We always start with right here, A. Here's your A value. Let's talk about A. The A value. These are the ifs. What you're going to know with A is it's going to affect your graph horizontally. It's going to horizontally stretch or compress your graph. And it may, if there's a negative here inside, it's going to reflect it over the y-axis. So, if A is negative, it's going to reflect over the y-axis. That's the first thing I want you to say. If you see a negative, it's a reflection over the y-axis. Then what you're going to do, you're going to take this A value and you are going to give me the reciprocal of it. Now, I didn't say opposite reciprocal, just reciprocal. So I want you to take that A value and flip it. If it becomes a fraction less than 1, like 1/4 in this one, if it's less than 1, we say it's a horizontal compression. If when you flip it, it becomes greater than 1, it's a horizontal stretch. So think of stretch, bigger than 1, compression, less than 1. So for A you're going to flip first. You're going to flip it. Reverse, take the 1 over this number. Okay, so what is 1 over 4? 1/4. So if A is less, after you flip it, if it's less than 1, you're going to say it's a horizontal compression. And I'm going to run out of room. I'm going to abbreviate, horizontal compression. So we flip it first. Do the reciprocal of it. You're going to flip it. If it's less than 1, we say it's a horizontal compression. If A is greater than 1, it's a horizontal stretch. Now, how do you do A on a T-chart? How do you do that? What you do is you will multiply the x values, and you can write this down. You multiply the x values by that flipped number. So in this case, it would be by 1/4. So this one we would say is a horizontal compression by 1/4. Okay? So how do you graph that part right there? You would take your table of values. The table that I'm talking about is when we did the parent function numbers. You would take all of your x values and multiply them by 1/4 to do that part right there. Then we move on to B. Here's B. Okay, here's B. What do you do for B? B is going to shift your graph left or right, the opposite of whatever that number is. This is a horizontal shift. So B is going to shift your graph. It's a horizontal. It's going to move it left or right. It's the opposite of that number. So you're going to say horizontal, 3 units, right. Now how do you do this letter B mathematically? You're going to take 3 and add it to the x values from here. So you would add 3 to the x value. Okay, so these two numbers right inside, they affect the x value. You multiply the x value by the flipped number here, and you add the opposite of the x value of whatever that is to the x, what you have on your t-chart. So far, are you guys okay? These are the transformations of the parent function, y equals x squared. How would you graph this?
Oh, that was supposed to say you get the x squared. I just thought we do a random problem.
Yeah, this is a random problem, but this is an example. It's a random example. So here's the parent function. We talked about how do you get the parent function. You have to be able to strip all this stuff out. And now you would take your table of values. How do you graph this? You would take your table and you would multiply the x values by 1/4, and then you would add 3 to them. Okay, now we're not done. Here's C. So inside horizontally compresses and stretches the graph. The inside right here is going to move it left or right, the opposite. What does this thing do? It's going to do a couple things right here. The negative, if there's a negative in front, it's a reflection over the x-axis. If there's a negative. So a negative inside is a reflection over the y-axis. A negative outside is a reflection over the x-axis. Now this number is going to vertically stretch or compress your graph. This one horizontally stretches it or compresses it. This vertically stretches it and compresses it. So if the C value is greater than 1, it's going to vertically stretch it. If it's less than 1, it's vertically going to compress it. So this is a reflection over the x-axis, this is your C value. Reflection over the x-axis, and this is going to vertically stretch by a factor of 2. How would you do this one mathematically? This, you multiply the y value by -2. So this one, you're going to multiply the y value by -2. And the last thing is going to move it up or down. These two move it vertically, these two horizontally. Outside vertically, inside horizontally. This is going to shift your graph vertically up 7. So if it's positive, it's going to shift it up. If it's negative, it's going to shift it down.
So you don't flip that one?
Nope, you don't flip these two. You flip this one and you take the opposite of that one. So if you want to, it's a good way to remember it. The two inside, you have to do something too. The two outside are exactly what they are. So this is a reflection over the x-axis, and the 2 is a vertical stretch by a factor of 2. this is a shift 7 units up. These are the two oddball ones right here. Now these two, you do something to the y value, these two, you do something to the x value. Okay? So let's do another example. Okay, let's put a negative in here. Put a negative in there. Okay, let's talk about the transformations here. Here's an example. So, I want my A, let's look at where A, B, C, and D is. So C, A. Now, why am I using parentheses? Think of the parentheses as just the absolute value now. Okay, so we start with A. Here's your A value right here. Should we do something to this problem first? Because B is going to be a little different than what I think it is. It's not 4, negative 4.
Or
What kind of 2?
Two.
So if we pull out the A value, what's left is X. What is this, plus or minus?
Plus.
It's plus. Why is it plus 2? Because negative 2 times positive 2 is negative 4. So watch that, you gotta understand that factoring. All right, so now here's our A value. Here's A. So what do we do first? Well, we're going to, this tells us it's a reflection over the y-axis. In the 2, we're gonna flip it, and what do you get? 1/2. This is gonna be a horizontal compression by 1/2. Horizontal compression by 1/2. What's that?
Would it be stretch if it's a,
You flip it, if it's a fraction, it's a compression.
I mean, it's less than 1? Oh, okay.
Yeah, flip it. When I say less than 1, don't look at the negative, just look at the 2. So flip 2, what do you get? You get 1/2. 1/2 is less than 1, it's a compression.
All right. thank you.
Okay? Okay, let's go to B. What do we do for B? We're gonna say 2 units right. I'm sorry,
Would it be,
it'd be left. It'd be left.
wait,
You do the opposite.
but wouldn't that be a negative 2 since you'd be subtracting the 2 from the x?
You wouldn't be
So it'd be
subtracting,
a-
you'd be plusing the x.
Minus the negative?
No, negative 2 times positive 2, that's gonna give you your negative 4.
But in the original equation, it's x minus b, so wouldn't that actually be minus a negative 2?
No, it's the opposite of this. So this is a plus 2, so you're gonna go left 2. You gotta think of it as the opposite. You're going opposite of 2, so you're going left 2. You're going left 2. This is a left 2. And it's horizontal. These are horizontal shifts. Stretches and compressions and shifts. Now let's do the vertical. These are the 2 vertical ones. Let's go to C. What would you say C is? It's a vertical something. It's a vertical stretch if it's bigger than 1. It's a vertical compression if it's less than 1. This one is a vertical compression by 1/3. Get it? So that's a vertical compression by 1/3. If this were a number like 3, 4, 2, 7, that would be a vertical stretch. So if it's less than 1, it's a compression. If it's greater than 1, it's a stretch. In the last D, you're gonna go up, vertically up. Seven units. Now mathematically, how would you graph this without a calculator? To get the exact graph, because it's gonna be crazy than what, you're used to. This is, the absolute value graph, it's a simple graph like that. But with all of these changes to this graph, it's gonna be moved left, right, up, down. It's gonna be squished closer to the x-axis or flattened closer to the x or the y-axis, depends on the number. But what you're gonna, if you wanted to do it without a calculator, you would have to do these steps in this order. And mathematically, what you would do for these two, you're gonna multiply the x value by -1/2. Then you would subtract 2 from those x values. And then you would multiply the y values by 1/3. And then you would add 7 to those y values. Now, I wouldn't ask you to graph something this crazy with these numbers, but these, I want you to be able to say these transformations. Okay? So are we ready? Now, I've shown you some hard problems. Let's look at some easier ones. Look at that first worksheet I gave you. And let's run through that. Does everybody have it? The one with all the lines? The 1 through 9 in front? All right, now, on this page, 1 through 9, what you notice is they're all the parent function on all of these is y equals x squared, the quadratic function, right? So your job is to tell, are these transformations an A, a B, a C, or a D? Okay? So looking at my little recipe, we have f of x. We do them in this order. We do C, A, x minus B, and then plus D. Not all of them have an A value. Not all of them have a C value. Not all of them have a B value or a D value. But you have to be able to tell what they are in order to say if it's a stretch, compression, shift left, right, up, down. So, do you understand the difference between A, the biggest one is A and C. Do you know where an A is and you know where a C is? So, for question 5, 5 has a -5 in the parentheses. That -5 is an A value. But number 1, that 4 is not an A value. That 4 is a what?
C.
A C. So you have to know the difference between what an A is and what a C is, because this is a C value, and we say C's are vertical stretches or compressions. Do you get that? So for number 1, how would you describe this transformation? What would you say? And I want you to write it with me. What would this be?
Vertical stretch.
Vertical stretch. By what?
4.
A factor of 4. So to do that, you would multiply your y values by 4 to graph this one without a calculator. You would, if you want to write that down, I don't care, multiply y by 4 if you want to do that. It's up to you. Number 2, what letter is that? Is it an A, B, C, or D?
B.
It's a B. So what would you say that transformation is?
A. Drop, subtract, 2 left.
2 left, yep. 2 units left. And that's a horizontal shift, 2 left. So how would you do that one? You would take your x values and you would subtract 2 if you wanted to do it mathematically. Take your t-chart and take all the x values in your table from the parent function and subtract 2, and that'll shift your graph 2 units left. Number 3. Look at it for a second. There's 2. Yep, they're both, what is it?
C.
It's C. It's C. Because there's no parentheses. There's 2, this is a C and that's a C. What are we gonna say for the negative? Reflection over x-axis, I heard it. Reflect over the x-axis. That's the negative. And what does the 1/2 do?
Compressed.
Vertical, yeah, vertical compression. Vertical compression by 1/2. Now, how can we do this letter C mathematically? What you do is you multiply the y value by negative 1/2. I hope this will help you out. Okay, number 4, is it an A, a B, a C, or a D?
D.
It's a D. This one is gonna vertically shift
2
down
units down.
2, yep. And how do you do that one mathematically? You take your y values and you're gonna subtract 2. Okay, number 5, is that an A, a B,
A and a D.
It's an A and a D, good. A and a D, we do A first. There's your A. So what does the negative do?
Reflection over
Reflect over the y-axis, good job. And the 5, what do we have to do with that 5?
the y.
Flip it, and it's a horizontal,
Compression.
good. Horizontal compression by 1/5. Now, how do we do both of these? We multiply the y value, or sorry, the x value, multiply the x by negative 1/5. Multiply the x by negative 1/5. And what's the 3 gonna do?
Vertical shift it up by 3.
Up 3, vertically up 3. Good. Number 6,
C, D.
a C value and a B value. What comes first?
B.
B. Let's do B first. So what would you say? 1 unit?
1 unit to left.
Right.
Right, it's the opposite.
Oh.
Inside is opposite. So how do you do 1 right? You're gonna take your x values and add 1 to them. And how about this 3? A vertical
Stretch.
stretch, good. Vertical stretch by a factor of 3. And you're gonna take your y values and multiply them by 3. So take your y, I'll just write 3y. 3 times the y value. Number 7, what letters do we have to deal with?
An A and a D.
A and a D, good. A. What's A?
Horizontal stretch by 4.
Good, horizontal. Horizontal stretch by what?
4.
Good. You guys got this. Horizontal stretch by 4. And how would you mathematically do a horizontal stretch by 4?
You multiply x by 4.
Good, 4 times the x values. You got it. And what would the minus 7 do?
Move it vertical down.
Vertically down, and I'd be happy if you just said down 7. And this, you would take your y values and subtract 7. Take the y and minus 7. And we have 2 more on this page. What would number 8 be? We've got 3.
A C, a B, and a D.
Okay, what should we do first?
B.
Yeah, B is right there, 4.
Horizontal left.
Left 4. Okay, and then what?
Compress two
Uh,
Or no,
compress
yeah, X.
two.
over the x-axis.
Let's do the, reflection,
Wait, why is it? Oh, because the C.
reflect over x-axis is good. Then what?
Okay.
Vertical what? Is
Stretch.
vertical stretch by a factor of
2.
2, good, and last thing,
Down 1.
one up. Now, how would you mathematically do this one? This is a good one, do you know?
You subtract 4 from x.
You would do x minus 4, I agree.
And
Yep.
then you multiply y by -2.
Uh-huh,
And then you multiply y by,
you mean add 1
oh yeah,
Add
one,
one.
sorry.
to the y value, so the
Mhm.
y value plus 1, perfect, good job. Okay, the last one, number 9.
C, B, D.
We've got a C value going, we got a B value, and a D. What comes first?
B.
B, let's do that one. 2 units,
Right.
right,
Reflect over the x.
reflect, I'm just gonna write RO, reflect over. Is that okay? Reflect
Mhm.
over x-axis,
And vertical stretch of 5.
VS, is that okay? VS by 5, and what else?
Down 4.
Down 4. And how would we mathematically do this? How would you do the right 2? Take the x values and do what?
Multiply by 2.
Add 2. Take the x values and add 2. You add 2. And then you take, for these two, you multiply the y value by -5,
Subtract.
and then you take the y value and subtract 4. That's how you do those. Even though you're not asked to do it yet. I just want you to know. They flip to the back. Number 10. Now we're going to give you a parent function and tell you to do something to it. Can you produce the equation that goes with it? Let's see. Now think, if it's horizontal, it's gotta go inside, and it's opposite of whatever it is. If it's vertical, it's outside, and it's exactly what it is. So, number 10. I'm giving you the absolute value function, and I want you to horizontally, I want you to go 4 left. So 4 left means,
Plus 4.
where does plus 4 go?
X
And
plus
then
4.
inside parentheses.
Inside, yeah, inside. Did you think that's what it was? So plus 4 inside is 4 units left. See if that makes sense. How about the next one? Vertically up 5.
So you do f(x) equals x minus or plus 5
Vertically up 5. Where does the plus 5 go?
on the outside of
On
x.
the outside. On the outside. If it's vertical, it's outside. If it's horizontal, it's inside. Okay, number 12. We're gonna vertically stretch. Stretching this vertical outside, horizontal inside. Where do we put this 3?
On the outside.
On the outside,
Front.
okay, 13. We're gonna horizontally translate this 2 to the right. 2 to the right, horizontal, it's the opposite one, so what do?
Minus, wait, x minus 2, I mean plus 2.
It's gonna be, is it a -2 or +2?
Oh, minus 2. no, sorry.
Minus 2, and it goes inside, right?
Yeah.
Inside is horizontal. Number 14, we're gonna vertically stretch this by a factor of 2, and we're gonna horizontally we're gonna do 2 things, and we're gonna horizontally translate it 1 to the right. So the vertical stretch, by 2. Does that number go out or in?
Out.
Out. So it's gonna be a 2 out. And then the one to the right,
-1.
X+1.
there you go, x minus 1. And that's, the horizontal one is the opposite, so it's right, so it's minus 1. Okay, next one, number 15. I want to take the graph of x squared and I want to reflect it over the y-axis.
So it's
So where do you
negative.
put a negative, inside or outside?
Inside.
Inside. And I want to horizontally stretch it by a factor of 2. This is a hard one. Horizontally stretch it. So what number goes inside?
-2.
Negative
1.
1/2. Negative 1/2. That's a hard one. So you would do negative 1/2 x squared. That's going to reflect it over the y-axis. And horizontally stretching it, you want to flip that 2 to make it 1/2. Next one, 16. We're going to horizontally compress this by a factor of 1/3. We want to reflect it across the x-axis and we want to vertically translate it 3 down. So think for a second, we're getting harder. So we want to horizontally compress this. What does horizontal do, inside or out?
Inside.
Inside. So. So what are you gonna do with the horizontal compression of 1/3?
It'd be
A 3, where?
3 on the inside.
On the inside, good. A 3 on the inside. We want to reflect it over the x-axis.
Because there was a -2 on the outside.
A negative outside, just a negative,
Just negative.
and we want to vertically translate it 3 down,
So to
Three
-3.
on the
outside, just like that.
What'd you put?
You don't need any parentheses. Just like that's good.
I'm a little confused on like the reflecting over the axes. Like, okay, if it's outside, it would be reflecting over the x-axis. If it's inside,
Inside
it's
reflect is
y.
y.
Okay, I was a little messed up.
Didn't you guys do reflections over axes in geometry last year? I know you guys did. We'll talk more about it. I'm just giving you a general idea of what these look like, and then we're gonna look at some graphs. 17, can you tell me what that one, vertical stretch by 3? Where does that go, in or out? Out. So a 3 goes out. It says vertical.
-4.
Horizontal translation 4 to the right, yep, x minus 4, yep,
And then.
and then vertically translate it 2 units up.
+2.
Good. Last one. This one you're gonna reflect over the y-axis,
That's a negative inside.
negative inside. Negative inside. Okay. We're gonna horizontally stretch this by a factor of 2.
So it'll be plus
One
negative.
Mm-hmm. 1/2. And we want to vertically compress this by a factor of 1/2. 1/2 on the outside. And we want to horizontally translate it 5 units left.
Plus minus.
Ooh, let's see if you can do this one. Horizontally translate 5 left.
+5.
Okay.
Plus 1/5.
All right, if I do plus 5, I have to put parentheses there. Or I have to do a minus 10,
Wait, why?
because it's 5 units left. If you don't have parentheses here, then if you just do this, if you do -1/2 x plus 5, this is not 5 units left. This, you'd have to divide this by -1/2. So if you put the parentheses around it, now it's 5 units left. Now, if you had a -10 here, then it would be okay. Then you don't need the parentheses. And then the last thing is 3 units down. Okay? So for homework tonight, what you have are, is it 6 graphs?
No, it's 8.
No, there's only 6.
Yeah.
2 of them don't have equations.
Oh,
So what you're gonna do on these 6, it should take you about 5 minutes to do, really. 5 minutes.
are we writing something like that?
You're going to write, I want the parent function, I want you to graph the parent function. So for this one, it'd be absolute value of x. I want you to graph it. These are not harder than what we've gone over, they're easier. So everyone should be able to do these for homework. I want you to describe the transformation, so state the parent function, and then this has 2 transformations. I want you to graph the parent function and the new graph. So this would be 3 units right and 4 up. You don't have to really make a T-chart, you can just shift your graph 3 right and up 4 and then draw the new graph. These should be pretty easy to do. There's 6 of them. So you can do that one with no problem, that one should be no problem, that one, and then just these 2 back here. If you run into trouble, they will be on YouTube, and you can, watch me I will do all 6 of them on, so you should have these done tonight.